and the motility of those organs, and the activity of the pancreas for insulin release. Then our post-absorptive state, glucagon is going to be released under influence of the sympathetic nervous system. Okay? So for sympathetic, well, we need more glucose, we need more energy availability. You're going to have higher levels of glucose in the blood, and so you're going to see that as a result of stress along with some other hormonal effects. So glucagon is going to do the opposite for fatty acids and for glucose. Also, the pancreas is going to elevate glucose and elevate fatty acids. It doesn't do much for amino acids.
Which cells make that?
Pardon?
Is that the beta cell also doing glucagon?
Alpha. They're both within the islet, though. So this is our post-absorptive hormone. All right? Now, insulin, all of the hormones we're going to describe today are all going to increase blood levels of glucose except for two. Insulin decreases glucose. What other hormone do you think is going to increase glucose levels?
Glycogen.
Pardon?
Glycogen.
No. Glycogen is not a hormone. Thyroid hormone. All right, so if we think about it, thyroid is the one hormone that you guys recognize as having an effect on metabolic activity. So thyroxine, T3, T4, it has a variety of names for its component effects. And it affects the mitochondria making ATP. So what's our primary carbohydrate source for ATP? In a normal digestive state, glucose. And so increased ATP synthesis means more glucose is being utilized and taken out of the blood for our body cells to incorporate in the mitochondria through the process we talked about on Friday. So we're going to see decreased levels of glucose. Again, the only other hormone other than insulin that we talk about that does this. So T3, T4, thyroxine, thyroid hormone. Obviously thyroid gland here. So with this use of glucose, and we talked about thyroid hormone very first week of class this semester, as long ago as that seems. And this is also necessary for alertness. You guys might want to bring forms of glucose to suck on during your exams this week and next week. Make sure your brain has energy sources. But not only is someone who's hypothyroid have difficulty with cognitive function, but if this hormone is low in infancy, it can result in permanent levels of mental disabilities, all right? Because along with lipids that are necessary for myelination, it's necessary for brain. There's a lot of brain development that occurs in the first few years of life. And without sufficient glucose levels, rather than being a temporary, an adult, it's a temporary loss of the ability to think and so on. That becomes permanent in very young children. All right, that brings us then to growth hormone, which on the surface, on the appearance, is a great weight loss drug. In fact, on the Sunday morning radio shows, I often hear sale pitches for pre-growth hormone, precursors to growth hormone, anabolic type steroids. And when you look at it, growth hormone, and this is actually a very complicated hormone. It actually works on a variety of cells. It causes the liver to produce actual downstream chemicals that have a lot of its effect, insulin-like growth factors and other components that we're not going to get into. But growth hormone pituitary gland here. Switches fuel. So it's involved in gluconeogenesis trigger. It switches fuel from glucose to fatty acids. All right. So we start, and it's a kind of a conundrum when you first look at it. It causes the lipase enzyme, not pancreatic lipase or salivary lipase, but within our adipocytes, within our fat cells, we have the enzyme lipase. And so it causes more of those enzyme molecules to be produced. And so the adipose cells, the adipocytes, break down triglycerides and release the fatty acids into the bloodstream for use as fuel. So our fatty acid levels go up. Those are used instead of glucose, and we're not using our glucose, so those levels go up. But we're breaking down fats, and then the proteins, the amino acids that are in the blood, are used to make new proteins. So we're building muscle and we're losing fat. Sounds like the perfect kind of weight loss drug. Get rid of the fat, make muscle. So we're gaining fatty acids because we're breaking down fat cells. We're losing amino acids because we're taking that out of the blood to make new muscle protein. We're not using glucose since we're using fatty acids. The glucose levels rise in the blood. And herein lies the problem. So someone who uses these growth hormone precursors or anabolic steroids for a long period of time has long-standing elevated glucose levels, which tends to result in type 2 diabetes. As the insulin, the pancreas becomes, quote-unquote, worn out. So that is why it doesn't work for a long period of time. In fact, there was a case study, I'm not sure if I even had it listed for this unit, where I had a bodybuilder that was on growth hormone components and developed diabetes, okay, as a result of the long-standing elevated glucose levels. Okay, that brings us to the adrenal gland. We looked at the adrenal gland, the first part of the endocrine system, just for its location. And if you recall, the adrenal gland has a cortex and a medulla. And we have hormones released by those two different regions. So we have corticosteroids from the cortex and neural hormones from the medulla. So if we look at that cortex in a little bit more detail, here are the three different types of corticosteroids. We have androgens, forms of testosterone, both male and female adrenal glands. All right, and this is where the bearded lady from the circus often comes from, a tumor of the adrenal gland. And we have our mineral corticoids, the aldosterone that we just got through, or you guys might still be working with, in the urinary system. So regulating sodium and potassium. And then primarily, the adrenal cortex releases glucocorticoids, which are cortisol. Now, glucocorticoids, cortisol, is an anti-inflammatory. This is what's being used in steroids, so someone's getting prednisone pills or getting steroid injections into arthritic joints as an anti-inflammatory. Okay? But it also reduces healing. It's produced under stress. So in a stressful situation, you're going to get elevated levels of cortisol and you're going to get elevated levels of epinephrine, which is our medullary, our neural hormone. So cortisol, we talked about this very briefly last semester, at the beginning of this semester. Let's see if I have room here. So with cortisol, we have let's see if I can put an image in here of a typical Cushing's individual. So a typical Cushing's individual is going to have the buffalo hump, I'm exaggerating everything, a moon face, big belly, very skinny limbs, striae, stretch marks from the expansion and changes in size, a hump of adipose tissue at the neck, the round moon face at prednisone. Often you see patients that are on prednisone, someone who may have lupus often develops. So what cortisol does is it shifts, it's also a gluconeogenic hormone, and it's a glucose conservation. All right, so glucose levels are going to go up because we're not using glucose. And proteins are being broken down. So protein levels are going to go down. That's why the limbs are so skinny, because that's the source of nutrients. Yeah, I can change this here. We're breaking down proteins, so amino acids are going to go up. So amino acids are going to go up because we're breaking down proteins. Glucose is going up because we're not using glucose. And then fatty acid levels go up as well. Okay, so for gluconeogenesis, we're increasing amino acids and fatty acids and then not using glucose. All right? So whenever, for this thing, when you see an increase in amino acids, proteins being broken down. When you see an increase in fatty acids, fats are being broken down. When you see an increase in glucose, glucose is not being utilized and it stays in the blood. It's not being taken up into the cells. So that's the reason for those components. So this is the hormone that is being attacked or referenced to. You see those ads on TV where there's a couple and she says, you know, I go to the gym and I exercise and, 4 hours a day, and the only thing that gets smaller are my boobs, and here's my husband, and his shorts fall off because he's losing weight. All right, so it's talking about cortisol is an inhibitor of weight loss for many individuals. So even though it says lipolysis here, there's weight deposition that occurs in the abdomen area and along the shoulder area, between the shoulder blades. Then the last hormone is norepinephrine. Those are the striae I was talking about. Okay. Sometimes they're very dark purple when they first show up. But this is the moon face and the face, the plethora, the flushing of the face. Those are, so many doctors are trained into what I've drawn. This is the Cushing syndrome. But when it appears without those factors, they don't recognize it. And so, in many cases, it might take them 10 or 15 years to be diagnosed because someone doesn't present in the classic form. And so, these people are overweight. They're the typical, often apple-shaped appearing person that we talked about on Thursday. And they're told to just go lose weight. And they go and they work and they work and they work and they get discouraged because they seem to be doing twice as much work and not losing weight because of the cortisol's effects. All right, finally, we have then epinephrine. And it's going to be, again, a factor similar to glucagon, increase in glucose and increase in fatty acids. It's another stress type hormone. So very almost identical to glucagon as its effects. Alrighty. So on the lecture exam, I'll have a table that has these hormones. I'll give you the hormones. I won't give you the effect and then ask you to identify the hormone. It's a little difficult. I'll give you the hormone, ask you what organ produces it. So these two are adrenal gland. And then I'll give you one or more of these and just put an up or a down arrow. Okay? So components of that information, not the entire table.
You mentioned norepinephrine, but it's not on your list.
Epinephrine and norepinephrine are the same.
Okay.
Epinephrine is primarily what's made in the adrenal gland. Norepinephrine is more of a drug, rather a neurotransmitter rather than specifically from the adrenal gland.